Hi, this is Matt in Phuket, Thailand, and the topic of this video is an idea. A simple idea that has the potential to change a lot of things in the world we live in the next 20 years. So if you Google Satoshi white paper, you're going to find a document of about 8 pages that in plain English explains how the idea works. And the idea is just one sentence, is to shift from having to rely on a trusted third party for transactions and instead replacing that with relying on the consensus of a large number of nodes that you don't trust. So that sounds really weird, sounds really wacky, but it actually does work in real life. It was proven. So having to trust a third party, what does it mean? Well, if you take the example of you go on holiday, you take your passport with you, you go through border control, you're going to show your passport to border control. The only reason why the people let you go through is because they trust the government that issued your passport. So they trust a third party. When you do any transaction at a restaurant, you're going to buy a meal, you pay with a credit card. So you hand over your piece of plastic to the clerk. The only reason why the clerk accepts the transaction, or you're not giving any cash, you're just giving plastic. The only reason why he accepts the transaction is that because he trusts the bank that issued the card. So again, this is a third party. But even if you look at cash, you hand over cash to someone, that person is going to accept the cash for the transaction, not because the notes have any value in themselves, but just because they trust the government that issued the notes. They trust the government to redeem the notes. Now, if you're moving away from money, if you just look at authentication, IT authentication, and in particular web authentication. In the past few years, you've seen OpenID, OAuth, which are technologies that allow you to authenticate on a website by choosing an arbitrary third party to validate the authentication. Again, you rely on a third party website that both parties trust in order to validate the authentication. Well, forget money and authentication. Just look at the architecture of any IT systems. It's all based on the client-server model that has been there for ages. If you look at Facebook, Dropbox, or even your bank, it's in its simplest form, the bank, what it does is that it moves money between client accounts. And in order to do that, inside the backend systems of the bank, you've got central databases that maintain clients' balances. So this has drawbacks. There are issues associated with that. Why? Because this creates single points of failure. It also creates security issues. This is having a central hub means you have a bottleneck that creates performance issues. And this all has a cost. It's relatively slow to run as well. So a lot of people would potentially be very interested in having an alternative to this model. The full-size experiment that proves that this technology is possible is Bitcoin. Bitcoin is electronic cash that allows you to send cash to anyone in the world very cheaply and very fast. In terms of security, it is really equivalent to cash. If you lose your private key, you lose access to your wallet and you lose your money. If you wanted to store a large amount of Bitcoin at home, you would have to print out the private key on a piece of paper, lock the piece of paper inside a safe, exactly as you would do with actual cash. So how do you use it? You connect to bitcoin.org and you're going to download a client. The default wallet for Bitcoin is called Bitcoin Core. It's a program that you install on your computer, and this is a peer-to-peer client. So this is going to connect to all the other nodes on the network. It's going to broadcast messages to all the other computers that also installed this client. The key thing here is that there is no connectivity to a central server. This is the key to this technology. There is no reliance on a central server. The people who created it, they can't actually stop it because there is no central server. It is unstoppable. And from that respect, it's quite exciting and at the same time a bit frightening. The other key thing of the technology is the transaction validation, which is done through consensus. So those transactions have to be validated somehow, and they're validated by all the nodes together. And one particular thing that has to be validated, among others, is the transaction sequence. You have to somehow record the transaction sequence to prevent double spending, is the only way. Now, inside a distributed system, recording transaction sequence is actually hard. This is not a trivial thing. You can't just write timestamps inside transactions. It can't work this way because you could not prevent a node from writing a bogus timestamp inside transaction. So the way transaction sequence is recorded is the most interesting part of the technology, and this is where special nodes called miners are going to be dedicated to encoding the sequence of transactions in a particular way. The mechanism to record the transaction sequence is the blockchain. All the transactions that are assumed to have taken place at the same time will be packed inside the same block, and the nodes that will be allowed to publish those blocks to the network are the nodes that manage to solve the input of a SHA-256 hash.